In the last video, we discussed about a separable differential equation, and also we started the linear first order linear differential equation, and I did one example from the book. Okay, so in this video, I'm going to do more examples. So the next example I want to do is question number 6 from the book. It says ty prime plus 2y equals to sine t. What we need to do is we need to draw a direction field and describe the behavior of solution when t is large from the direction field. Okay, also solve it and use it to determine how the solution behaves as t tends to infinity. So to solve this differential equation, first of all, let us see, this is linear differential equation. How do I know that? Is because you see that the general form is a function of t times y prime plus 2 times y equals to, there is no y there on the right side, right? So you can write this in the standard form. How do I do that? Divide both sides by t. What do you get? You get y prime plus 2 over t. So 2 over t times y. I'm dividing both sides by t, okay? Over sine t over t. Okay? This is in the form of dy over dt, right? So dy over dt. And then plus 2 over t y equals to sine t over t, right? So you can write this this is in the form of dy over dt plus pt p y plus q, where p and q are function of time, right? Now to draw the direction field, what we need to do is we need to draw t versus the y, right? And at each of these points, right? At each of these points, because we need to consider only t is greater than 0, right? Because that's what the question is giving. So at each point, we need to plot that into this equation, right? Actually, you should solve this equation for dy over dt, meaning that what do you see? Dy over dt equals to negative 2 over t y plus sine t over t. For each point, for example, this is 0, 1, 1, 0, 2, 0, 3, 0, 4, 0, and so on. 1, 1, 2, 1, 3, 1, 4, 1, 1, 2, 2, 2, 3. At each point, you plug in those values here. T is the first coordinate, and then y is the second coordinate, and then find out the slope. What is the value of dy over dt? And based on that, you draw a small, pointed line, right? Now, so to do that, that's by hand, but we have a very easy way to do that by using software. Okay, so what was the software that we were using last time for the direction field? Is actually we were using this software last time. So to draw the direction field, what you need to do is you need to enter this dy over dt equals to negative 2y over t, and then plus sine. You see that for the trig functions you need to parenthesis sine t over t, okay? And this is dy over dt. So since the question says t must be greater than 0, so what I did here is I took t is between 0, and then you can take up to 10 or whatever number you want to, okay? And then for y, you can pick negative 3 to 3, negative 5 to 5, it doesn't matter. So you can see that, you will see that whenever t is increasing, the solution curve sounds like they are going to 0, right? You see that? All of them are going to 0. Whether it starts from the negative initial values or positive initial values, they are basically going to 0 from there, okay? So what you can see there is, it looks like it is going like this, and then going to 0, right? So whatever initial value you take, like that, right? So for any values it is going. So what you can say here is, as t increases, y of t, that the solution goes to 0. That's what it is looking like, right? Okay, so the another thing we want to do is, so we did draw direction field and describe the behavior of the solution when t is large. Also solve it to determine how the solution behaves as t tends to. Now what we want to do is we want to solve this equation, this equation, because this is a linear. Okay, so we need to find out the integrating factor and then multiply both sides and then integrate and find out from there what happens to the solution. Okay, so here the integrating factor is obtained by e to the integral of p. What is p? P is 2 over t, right? This is p. So 2 over t dt. What happens to this? It is e 2 times 1 over t is natural log of t, right? So what does that mean? That means e to the natural log of t square, right? You can move this 2 to the exponent. So that is e and ln cancel out. So it is like t square. So we need to multiply both sides by t square. What happens if you do that? You get t square dy over dt, right? Plus twice t y equals to t sine t. That's what you get, right? Now on the left hand side, as we mentioned, the left hand side can be written as the derivative of y times the integrating factor t square, because if you use the product rule you will get exactly the left hand side. Okay, and then there is t sine t, right? Now what we want to do is we want to integrate on both sides. If you integrate on both sides, you will get y times t square on the left side, right? On the right side, you should use the integration by parts, right? How do you do the integration by parts? You do u and then dv here, right? So u is t, dv is sine t, right? So find the derivative of t is 1 cosine of t negative, right? And then 0 negative sine t. So you multiply, this one is the first positive multiplication and the second is the negative. So every alternative multiplication is the negative. So you can write this as negative t cosine t, right? And then negative times negative will be positive sine t. Okay, and then when you integrate you get plus c there. Okay, so what you get is y times t square equals to, you can write, let's write on the positive sign first, sine t, okay, and then minus t cosine t plus c, right? Now divide both sides by t square because you want to solve for y. So y equals to sine t over t square minus cosine of t over t and then plus c over t square. So what happens when t tends to infinity then? When t tends to infinity, this sine t will be either between -1 and +1. Cosine t will be -1 and +1. So if you increase the denominator, that will become 0, that will become 0, and that will also become 0. So we get y of t goes to 0. So either way, from the direction field or from the solution, you get the yt tends to 0. Okay, let us do one more example on this. So again, as previous one, so you divide by t and then get y prime by itself. So you get dy over dt minus 1 over t and then y, right, equals to t square e to the negative t. Okay, again, so here it is, t is greater than 0. So we need to do first, we need to plot the, so first of all we need to plot the direction field, right? So how do I do that? Is if you solve this one, you will get dy over dt equals to 1 over ty plus t square e to the negative t, right? So what we do is we need to use that app, direction field app, and then plot the values there. Okay, so dy over dt equals to, you write 1 over t y, or you can write 1 over 1y over t, right? And then sine y, instead of sine y there is t square e to the minus t. So t square times exponential of negative t. That's how you plot, right? And then look at that. So let me erase all the previous curve, and then you can see that. So what you see from there is basically what happens here is we are taking the smallest value of t is 0. So you see that if you pick an initial condition there, see, if you pick another initial, look at that. So for any initial conditions, so it is going away, right? It is going away from this number. So it looks like it is diverging, right? It is going to going up. So yt is going up. It looks like it is going to infinity kind of, or negative infinity. You see that? See, wherever you take those values, so these curves are diverging away. So that's what we want to write here. Okay, So what you can say here is basically, because see, t is always positive, right? If y, this e to the negative t is always positive for any value of t, and this is y. If y is bigger than 0, right, it goes up. You see that? If y is less than 0, it goes down. That's what we see here. So what we say here is, so as t tends to, or as t increases, y of t goes to either plus infinity or minus infinity. You can write that, you can say that way. Okay, all right, so that's what we did for the first part and the second part. Right now we need to solve this by using the linear method, right? So what we do is, this is the equation we take. So it is dy over dt plus p is negative 1 over t, y equals to q, right? So let us find out the integrating factor. So integrating factor is e to the p dt, that is p is e to the negative 1 over t integral, okay, dt. So what do you get? It is e to the negative natural log of t, because 1 over t has integral natural log of t, right? So this can be written as e to the ln t to the negative 1. That thing can go to the exponent, right? So that is e to the natural log of 1 over t. So e and natural log cancel out. So before you move that negative sign, you can cancel natural log and e. So you need to move that first and make this natural log free from coefficient to cancel them, right? So it is 1 over t. 1 over t is basically the 1 over t is basically the integrating factor. Okay, so what we need to do is we need to multiply all the terms by this 1 over t on the equation. So you get, so what do you get here? You get 1 over t dy over dt, right? So you get 1 over t dy over dt minus 1 over t square, because if you multiply by 1 over t to this, you will get negative 1 over t square y equals to, if you do 1 over t here, you will get t e to the negative t. That's what you get, right? Now on the left hand side, you don't have to do anything. You do just dy over dt, d over dt with the derivative of y times the integrating factor. That's what you get, equals to t e to the negative t. Now what we do is we integrate on both sides. Integrate. On the left side, the integral and the derivative will cancel out, 1 over t. So here you need to use the product rule, right? Or the integration by parts. You write u and then dv, right? And then u is t, dv is negative e to the negative t. So the derivative of t is 1. Derivative of e to the negative 2 is negative e to the negative t. And derivative of 1 is 0. Derivative of that is e to the negative t. So first diagonal is positive multiplication. The second diagonal is negative multiplication, right? So what you get here is basically negative t e to the negative t, right? And then plus minus, because this is negative multiplication. So you get minus e to the negative t. That's what you get, right? Plus c. Okay, guys. So what you get here, if you multiply both sides by t, then you get y of t equals to negative t square e to the negative t, right? And then minus t times e to the negative t plus c times t. That's what you get, right? C times t. All right. So now what you get is, what happens here is, if t tends to positive infinity, what happens is this goes to 0 faster than this t square. Okay, so this will be 0, and then this. So the yt depends on c. If c is positive, yt goes to positive infinity. If c is negative, yt goes to negative infinity. Okay, so hence, as t tends to infinity, then y of t goes to infinity if c is positive, and yt goes to negative infinity if c is negative. So that is the final answer for this problem. Okay, guys, in the next video we'll see some more examples.